And then that's the perfect introduction of the next subject, engine manufacturer, state of the art.
Maßnahmen zu weiteren Lärm.
So the next topic, engine manufacturers, status of research, implementation of planning measures for future noise emission reduction engines. And we've learned that the engines are getting bigger and bigger. We talked about bypass flow, but we also learned that it cannot be endlessly enlarged. We talked about nacelle lining. We learned about the broadband noise, which cannot be mitigated completely by the lining. So maybe you can elaborate on this kind of complexity. Dr. Christoph Richter from Rolls-Royce, a warm welcome to you. You've been working with Rolls-Royce for 10 years now, and you already worked on acoustic absorbers for engines during your doctorate. For 20 years you've been doing research in that area, and since 2020 you've been globally responsible for engine acoustics research and strategy at Rolls-Royce. And in your presentation you will show us rather complicated formula involving jet noise reduction, and you will probably explain why you're showing us these kind of formula. Then you're going to introduce the ultrafan to us, and you will also show us other aircraft concepts with different engines and explain what kind of impact it will have on noise. And then you are going to talk about research projects on low noise designs, and you're going to give us an overview of European research projects. And just for your information, maybe we can speed up a little bit. We've already answered some questions, and after the coffee break we have a long Q&A session. If it's okay with you, we will have our coffee break 15 minutes later than planned on the agenda. So we're looking forward to your presentation, and the floor is all yours. Thank you so much, ladies and gentlemen. Thank you so much for having me. Thank you for inviting me to this conference. In the year 2023, we cannot talk about aircraft noise without mentioning the net zero target and climate protection in general. And what you see here is the Rolls-Royce understanding. To achieve net zero carbon, we must ensure that all of our products are compatible with net zero carbon operation by 2050 at the latest. That's the only possibility we can become net zero. But now let's move on. This is my presentation. First of all, I would like to give you an overview on flight noise. Then what can Rolls-Royce do? What are the latest products? What about the research we're doing? And then I will end with my conclusions. This slide represents the ICANA Expert Commission goals. These are the environmental objectives. You can see the SRAs, the SRIAs, and the CO target stems from 2017. It has not been adapted yet, but it's still the target we have in the aerospace industry. If that is being combined with the sustainable fuels, we will have a CO2 reduction by 50%. As far as noise is concerned, the target is a 50% noise reduction. And some minutes ago, somebody asked whether it's a cumulative reduction or is it individual reduction, the 50%. But the target for 2050 is a 65% reduction in the amount of 15 dB less. And the target is based on the following expectation. We assume that air traffic will go up. More air traffic means more noise. You can see it here. This is the noise output, assuming the frozen aircraft technology, the red line. And noise will go up if we are not introducing new technologies. And this results from a study conducted in 2013 based on information we had in 2010. And with these technologies you can see, and this is represented by the yellow area, you can have a continuous zero line development, at least as far as the UK aviation is concerned. And when it comes to further noise reduction technologies, which are being introduced in 2025, we can reduce the noise dramatically. Another study is this one, the lateral noise development. This survey comes from DLR. You can see the engine noise was measured. You can see dominated by the fan noise, and you can see a reduction by 88%, 30 dB since 1950. So this is not cumulative, this is focusing on the engine alone. And the study was conducted in 2018, and the latest aircrafts have not been included yet, so we could reduce another more decibels. It's not full 10 decibels, a little less. And now let's take a deeper dive. Where does the noise come from? You can see the engines we are using, and you can see the different colors. Red is the jet noise, blue and green represents the fan noise, which is almost as high. Then you have the turbine, the combustion, and you have the condenser. So you can see four aspects which come into play. However, we can all have a positive impact if we adapt these four elements. And this is exactly the slide our moderator mentioned. Well, I wanted to show you how beautiful these formulas are, and I thought for quite a while whether I should show you these formulas or not. So we have the Force William Hawkins formula and the Lighthill formula. And if you do the calculation, you will come to this air flow and sound development. And this was made in physics, describing here, for example, the impact a rotor has and the blade have, and explain what is happening in a combustion chamber. Then the second formula describes the force which impacts the rotor and then causes the thrust. And here I can optimize something, and the third one describes then the jet noise. Honest sound generated aerodynamics development was the title of a study which was published. And you can see that if you influence individual factors like the bypass force, if you influence the size of the turbine, then you will have a different noise. Drag changes, for example. The drag of the nacelle is being limited. And this here is a graph coming from the 90s. You can see the bypass ratio 5:6 is optimal. This is where our turbines can be found here. And this was only possible with acoustic absorbers. And then the fan noise comes into play. Since then, the turbines have become bigger and bigger, the engines have become bigger. You might recall the first slide, the new advanced 3 engine, and our ultra fan is based on a bypass ratio of 15. On the far right-hand side, you can see it, and this is only possible if you reduce the fan noise, and the entire architecture is being changed. As a consequence, the CO2 emissions are not increasing. We can reduce them via smaller nacelles, via efficiency gains when it comes to all components we're using, and at the same time we're also reducing noise. So this kind of technology package, the ultra fan, which produces more than 50 megawatts, which has a diameter of 3 meters and 56 centimeters, which is quite big, and this is then a system which is improving all the different environmental aspects. So much about the conventional gas engines, and now let me move on with the electric engines. Here we won a record, a speed record, and here the propeller will probably be the main source of noise. And if you reduce that noise with the help of mathematical calculations, and a lot can be done here, then the electric propulsions and the hybrid propulsions will remain. This is what provides the aircraft with energy. And if you manage to solve this problem, you will have only the landing gear, which might cause additional noise problems. But electric drives are not always automatically louder. They can have tonal noise components which might annoy you. This is what Stefan Moal already said. New technology is not automatically a technology which is not that loud. And here a few words about business jets. Here you can see a big business jet and the smaller ones with Rolls-Royce engines being produced in Dahlewitz, describing the atmosphere research. With these vehicles, with these planes, you can transport, for example, small groups, and here the bypass ratio could not be increased, as these vehicles are flying very fast and very high. We increased the efficiency with acoustic absorbers, reducing, for example, the combustion noises, but we've also introduced the nozzle guide. However, there's one disadvantage. The mix needs energy from the main line, and if you use that, for example, you're taking energy from the main flow, and the energy needs to be provided for during the whole flight, which means that the efficiency goes down. And in addition to that, we have fan and other noises which need to be improved by an improved nacelle technology. Decarbonization is a complex problem. It does not mean automatically loud or less loud. We're using technologies which need to be further elaborated, and the right conclusions need to be drawn. The technologies we're using now in the fleet are defining sound during the life cycle, and of course we also have to think of CO2 emissions and the costs in this respect. CO2 emissions in a fleet, however, can be reduced if you're using this kind of sustainable fuels and sustainable aviation uses. At Rolls-Royce we have the Ultra Fan demonstrator. We would like to launch it in the test bed 80, which is brand new, and you can see our microphones we use for recording the sound, and in 2021 we won a speed record with it, and we have an engine which is run by hydrogen. And all these efforts were taken just because we want to be part of it. We would like to be the technology leaders for the future engines. So it's a lot of technology what we have. The European project Pulsar should add a little bit light to that scenario. And this brings me already to the research landscape in Germany. In the past, we were funded by the Federal Agency for Environment and Climate Protection, and we conducted lots of LUFA projects with partners like Airbus, Lufthansa, but also smaller companies, medium-sized companies. We focused, for example, on sound-optimized cycles, on fan technology, on the compressors and turbine systems, then new nozzle systems. Then when it comes to business jobs, we're already using, for example, new wing technologies to reduce the noise. And if you ask how do we know where the noise comes from, we have lots of microphones on the aircraft, and we try to measure as early as possible where the main noise comes from. But we also take vibration and deflection noise into account. On the next slide, you can see the European Noise Research Projects. Here we profited from so-called enablers. We could show, for example, that it makes sense that there is a benefit to reduce noise, and then we moved on with big demonstrator projects. At the moment, we have the ATEM project, new absorbers, technology, which is being implemented. However, the focus has always to be the climate protection, and from my point of view, it would be important to see that climate aspects are taken into account as early as possible, as you can't change them or influence them later on. And if you take the wrong technology decision, then you will see technologies being used in a fleet and you can't change it. I hope that I wasn't too long in my presentation, so this is the summary. Due to the continuous increase of the bypass ratio, we have lowered the jet noise. In addition to that, we've optimized turbo machinery, we've used CFD and CAA methods. We have significantly contributed in the nacelle improvement. This had an impact on efficiency and noise. We assessed different components and engine noise measures, which are still needed. The ultrafan architecture will enable the Rolls-Royce company and the customers of Rolls-Royce to see further improvements when it comes to the ACAR flight paths 2050 targets. Rolls-Royce is going to measure noise at a very early stage, and we believe that the CO2 exhaust rate can be reduced even while a fleet is operating. However, major technological changes cannot be made in a lifetime. And then I would also like to mention gliding aircraft, which cannot fly as steeply as other aircraft. And this depends, however, on the usage of a plane. Here at the bottom, I have a list of things, of requirements, which need to be taken into account if you develop new aircraft types. And this brings me to the end of my presentation. I already mentioned the Pulsar project, that roadmaps are important, and having said that, I would like to ask kindly thank you for your attention.
Ja, vielen Dank, Herr Dr. Richter.
Thank you, Dr. Richter. You may stay here because we will answer questions, and Mr. Stoker and Mr. Mole, please come on stage as well, because now we have the question round. You radiate optimism, saying no matter what technology you can do noise optimization, but you have to think of noise abatement right from the beginning. Well, not no matter what technologies, but with many technologies, we don't see that there is a negative impact. But they are not automatically good. You have to understand them first and then understand the optimization potential. And here I wouldn't lean out of the window yet, that I could see what technology proves to be most promising. Okay, thank you. If you want, you can take a seat.